G'day again, everybody. This is the second in a series of videos about vectors. Hopefully I'm going to edit this again soon, so this is just a start of it. This is about adding, subtracting, and multiplying vectors by scalar. Okay, let's talk about addition of vectors. There's one vector rt, it's 5, -2. There's another vector ts, -1, 6. I want to add them together, and I do that by attaching them from tip to tail. So the end of vector rt is the beginning of vector ts. It's easy when they've got the same letter. So when you add them together, you get vector rs. Just think of it as starting here and finishing here. To get from r to s, you can go straight along the red line, or you can go from r to t and then t to s. The and then means add it together. Now, to work out what vector rs is, you can look at the graph, or the diagram there, and you can see that the answer should be 4 in the x direction, 4 in the y direction, 4, 4. But if you look at the answers here, if we add 5 and -1, if we add -2 and 6, we get 4, 4. So there you go. Works graphically, it works algebraically. AB plus BC equals AC. You can check those numbers yourself. Here's two more examples. Okay, you can see how the red vector there corresponds to the answer here when you just add the other vectors. Before we get to subtraction, here's something important. Vector AB, we can call it vector A. Okay. AB are capital letters because they're the names of points. Small letter A for the vector. And see how it's bold? We've got to distinguish it from just a small letter A. Make obvious that it's a vector. When you're writing on paper, you can't really do a bold, so put a little squiggle underneath it. If two vectors have the same size and direction, we can call them both A, or whatever letter you choose. If they're the same size but opposite directions, pretty obvious, I'm sure you can guess. It's just -A. So if I want to subtract two vectors, I've got vector P and I've got vector Q. If I want to do P minus Q, it's better to think of it as P plus -Q, because adding vectors graphically is really easy, because you just go from tip to tail. And the resulting vector, or the resultant, is from the start to the finish. So P plus -Q is P minus Q. It works graphically that way, but really simply, just putting in the points, you just have to subtract it, and it works out even more easily that way. There's a theory or a rule. I don't think you need to remember that because it's so easy in real life, but that's something to help you. We've done adding and subtracting. We also want to multiply by a scalar. Okay, if we multiply vector A, you see this vector A here, by 2, we get vector 2A, which is twice as long but the same direction. Multiplying by the scalar doesn't change its direction, only changes its magnitude. If we multiply by -1/2, the magnitude is halved, and also the direction is directly opposite. Okay, the opposite direction. If you look at the numbers here, AA is 3, 3, 2A is 6, 6, and negative half A is negative 1.5, negative 1.5. There it is in symbols. Vector A is AX, AY, AZ, so negative A is going to be negative AX. You can read that for yourself. And same when multiplying by a scalar K. Here's a little quiz for you. Pause the video for a second and try and answer these, and then I'll pop up the answers. Okay, I think that's enough time. Here's the answers. I hope you got that right. Stay tuned for the next video.